Welcome to lesson 35, identifying linear functions when you're given an equation. So that's our look for today. We're going to look to see if we can accurately identify a linear equation in y-intercept or standard form. So you can see it in y equals mx plus b form, or you can see it in ax plus by equals c form. And being able to accurately identify when something is nonlinear and being able to explain why. So let's jump in. There are three rules we're going to look at. So for one, all linear equations, we can write them in that standard form, that ax plus by equals c form, or you can write them in y equals mx plus b form, which is a slope-intercept form. And these are the three rules you have to follow in order to identify a linear equation and distinguish it from non-linear. So here's our first rule. And the first rule is that their exponents for x and y have to be to the first degree. Remember when we talked about that before? Well, polynomials. First degree meaning there's just an x, there's just a y, there is no exponent here. Like I know here there is an invisible 1, but if you see, for example, y to the second power, that is a second degree exponent, doesn't count. So in standard convention, we don't see the 1. So as long as you just see an x or a y, then it is fine, it is in the first degree. So we have some great examples here. You can see down here, y equals 2x plus 5. They're both to the first degree. And the same thing, 3x and 2y, these are also to the first degree. Now, the non-examples, you can see them right here. That's the very first way you can recognize nonlinear with exponents more than first degree. So when we see that, we know it's not going to be linear. And I'm actually going to go a little later and go on Desmos and show you what those graphs actually look like, so you can kind of see what the difference is. Let's go to rule 2. Second rule, x and y cannot be multiplied together. They have to be two separate variables in your equation. So in the first example, at first you may think, wait a minute, what's happening? Well, x and y are still separated. They're still different expressions. So even if you distributed, you would get 2x plus 2y equals 5. That's fine. They're both separate from each other. And in our second example, negative y minus x equals 1, that's fine as well. They're separate. However, if they are together like this, then no, it is not linear. It's going to be a very different shape. It will not matter. Those two would be impacting each other. Let's go to the third rule. And the third rule, another simple one, x and y do not appear in the denominators, in the exponent, or inside the square root symbols. Can't happen. So it's okay in this example over here, 1/2 x, that's fine. It's not in the denominator. Now, what if you have x over 2? Well, we know that this just means we can rewrite this as 1/2 x. Okay, so I'm just rewriting it in another form using an inverse operation. So if you have x over 4, well, that's just 1/4 x. Okay, because I can multiply x by a fourth, and that would be the same as dividing x by 4. So that is okay. Your x can be in the numerator, but it cannot be in the denominator. So for example, this, not the same. 2 divided by x, no, makes a different graph. Or x to the 5th, different graph. And definitely with square root x minus 5, these would all not give you linear graphs. So I thought it might be actually a little bit fun to see what those graphs look like, the nonlinear ones. just so you can get an idea. So I'm going to look at column 1, the very first one, where it says y is equal to x squared. All right, there's y equals x squared. It's definitely not a straight line. It makes a different shape. This would be a parabola. Let's look at the second one. X to the, and I'm gonna move it up to the third power. There we go. Plus 5. It already looks funky. Look at it, that weird shape. Is equal to y. So look at that shape compared to the other. So when you have an x to the third power, it makes this weird, like it goes up and then trails, it looks flat, and then it goes up all over again. And then here's the last one. It has y to the second power is equal to x. So look at this funky one. So here are the 3 different graphs, and it looks kind of like the first one except to a side. So it's a parabola just tilted over. So when you have those exponents, look at the different shapes that can happen. You can actually imagine if you had x, let's put y equals x to the, and let's play with it and do the 4th power. What do you think it's gonna look like? It looks, let me delete the other ones for a second. I mean, it looks like a parabola, just like with a flat bottom. So that's always looking funny. So what do you think it would look like? Let's go actually back up and let's look at it to the 5th power. And it looks like that other one, that to the 3rd power, but a little flatter. So this is where it gets really interesting. Here's to the 6th power. So notice it's flattening out. So this is what happens when you have exponents in your equation. It is definitely nonlinear. Let's look at the other one. Like, what would happen if I put xy is equal to 2? So here's xy equals 2. It doesn't even make one graph. It has 2, and that looks pretty funky, doesn't it? So this is what happens when your x and your y are multiplied together. It makes a very interesting looking graph like this that you're going to learn about much further along in high school. And let's look at the rule 3 when it's in the denominators, what this looks like. So we have y equals, and I want to put it as a fraction, 2 divided by x. It looks like that same example we had before, doesn't it? That when x and y is together. And that makes sense because you just divided by x to get to the other side. And let's look at y equals 5 to the x power. Let's put that in there. Ooh, it's flat. It looks really, really kind of flat, and then it gets super wide, getting really, really fast, really high. So that's what that one looks like. And what do you think that square root symbol is going to look like? Let's see if I can even find it here. So y equals square root x minus 5. And here's what it looks like. It looks like half of a parabola, like just a piece of it, just one arm going out. All right, so that gives you just an example looking at these rules. Let's make it bigger again so you can see all the things that can happen. They're definitely not straight lines. Okay, so knowing that, let's look at these here. Is it linear? Is it not? So take a moment, take your first guess. Which one is linear? 3, 2, 1. Bingo, this one is linear. It's to the 1st degree. So it follows the first rule. It follows the second rule. You do not have x and y multiplied together. And it follows the third rule where it is not, there's no square root symbol. It's not in the denominator. X is not in the denominator. So this is definitely a 1st degree. It is linear. Whereas my second one, it is not linear because we have x in the denominator. Okay, so hopefully you found that really helpful. It's actually pretty simple to recognize linear versus nonlinear, especially when you're looking at that first rule. So use that as your guidance for today. And if you're curious, open up Desmos and just put in the equation and see what it looks like. And you'll be able to tell, is it linear, if it's not. If it's a straight line, it's linear. That's it for today's lesson. I'll see you in the next one. Take care.